When HIP 65426b was first spotted orbiting a young star, it didn't make sense. This massive exoplanet shouldn't exist, at least not according to current planetary formation theories. Its sheer size, age mismatch, and isolated position challenged the idea that planets form slowly from debris around new stars. But HIP 65426b is just the beginning. One after another, the James Webb Space Telescope has uncovered objects and patterns that don't fit into the neat timelines and laws scientists have trusted for decades. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. Ancient galaxies that look too mature for their age. Gravitational lensing so perfectly aligned it defies probability. The telescope isn't just observing space, it's exposing cracks in the foundation of cosmology itself. These aren't random anomalies, they're piling up into a pattern that suggests something deeper. Galaxy J418's near-perfect Einstein ring hints at hidden symmetries. Vast, grid-like filaments stretch across intergalactic space with unnatural precision, and perhaps most unsettling, light pulses from an empty void repeat like signals, too regular to ignore. Each of these findings points to a universe far more structured, intelligent, and possibly intentional than we ever imagined. As the data accumulates, one truth is becoming harder to deny: what James Webb is seeing doesn't just challenge our models, it questions the very nature of the cosmos, and maybe our place within it. The James Webb Space Telescope has just done something that few thought possible. It stopped the world. Not with a bang, but with the quiet, brutal force of revelation. A new set of eyes turned toward the cosmos, and in that gaze, everything we thought we knew started to fracture. This isn't just about sharper images or deeper fields. This is about contradiction, disruption. It's about staring into the past and seeing things that shouldn't exist. Galaxies that are too big, too old, too perfectly formed. Structures with symmetry so exact, they defy the randomness of cosmic chance. And planets massive, hot, impossibly placed, circling young stars like they've been there forever. From the moment James Webb opened its lens, the anomalies began piling up. What was supposed to be confirmation became confusion. What was expected to reinforce the standard model of cosmology is now threatening to unravel it. Start with the deep field. Billions of light years away, galaxies appear fully formed just a few 100 million years after the Big Bang. Not fragments, not chaotic blobs of hot gas and dust, but mature, spiral-structured galaxies, at a time when, by every accepted theory, such formations should have been impossible. The laws we trusted to explain cosmic evolution suddenly look incomplete. The timeline doesn't hold. The universe, it seems, got organized far faster than it had any right to. Then there's HIP 65426b, a massive exoplanet orbiting a young star. It wasn't supposed to exist, not like this. Current planetary formation models can't explain it. Not with that orbit, not with that size. The conditions required to form such a planet don't exist in that system. Which leads to a darker possibility. Maybe those models were never right to begin with. Maybe this isn't the first cycle of star and planet formation. Maybe what we're seeing are remnants, survivors from previous universes. Or signs of formation processes we've never even imagined. The anomalies don't stop there. One observation stands out in particular: a nearly perfect Einstein ring. A gravitational lens so precise, so circular, so mathematically clean that it borders on absurd. This isn't how the universe is supposed to behave. Gravitational lensing is messy. Mass distorts space, but rarely with symmetry. Yet here it is. Galaxy J418 bending light in a ring so flawless it's hard to call it coincidence. That level of precision suggests alignment across unimaginable distances. It suggests order. More galaxies follow, more patterns emerge, and the patterns aren't just local. They stretch across cosmic scales. Intergalactic filaments, forming grid-like webs, clusters of galaxies arranged in symmetrical distributions, as though following rules we haven't yet deciphered. When you start mapping these formations across billions of light years, the randomness begins to fade. What's left is structure, geometric regularity, hidden symmetries in the void. These aren't artistic impressions or wild theories. These are hard data, published and peer-reviewed, pulled from infrared spectra and redshifted light. This is the universe on display. And it's not playing by our rules. Then there's the darkness between. The voids. Areas of seemingly empty space where something is bending gravity, but nothing can be seen. No stars, no galaxies, no matter, at least none we can detect. And yet the gravitational lensing is unmistakable. Something is there. Something massive, something structured. This isn't the chaotic, diffuse dark matter we've modeled in equations. This looks intentional, condensed, shaped, as if it's holding a form, as if it remembers what was once there. Which leads to the next break in the chain. Because if dark matter is structured, if it carries information or preserves alignment, then the implications are staggering. It's no longer just a placeholder for missing mass. It becomes something more. A framework. A memory system. A record of what the universe has been, and perhaps a guide for what it will be. This isn't speculation. It's deduction. When you strip away every other explanation, what remains is a possibility that makes scientists uncomfortable. Because some of what Webb is seeing doesn't just look structured, it looks designed. No one's saying that out loud. Not in those words. But behind the datasets and conference calls, the whispers are growing. Perfect symmetry. Improbable alignment. Formations that should never have emerged from chaos. Signals that repeat. Yes, signals. In a region of deep space, previously assumed to be empty, Webb detected light pulses. Regular. Rhythmic. Repeating. And not from stars or quasars. Not from anything we know. Just empty space, flickering in a pattern no natural process can yet explain. Maybe it's interference. Maybe it's an error. But maybe, just maybe, it's not. Because when you start lining up the anomalies, the picture begins to shift. Galaxies too old for the early universe, planets that shouldn't have formed, gravitational lenses that form perfect circles, dark matter that behaves like scaffolding, patterns across the cosmic web, and now, signals from the void. One anomaly is a mystery. A dozen is a challenge. Hundreds. That's a system breaking down, a model that no longer fits the data. Some theorists are quietly proposing alternatives. Not tweaks, but overhauls. Ideas once considered fringe, like cyclic cosmology or multiverse echoes, are gaining ground. The Big Bang, once seen as the definitive beginning, is now under review. Maybe it wasn't the start. Maybe it was a phase. A reboot in a larger repeating pattern, or something stranger still. Maybe it wasn't natural at all. There's even talk of intelligence. Not life, in the way we define it. Not civilizations sending radio waves across the stars, but embedded intelligence, cosmic-level design, a universe that knows what it's doing, one that remembers, one that evolves not just physically, but informationally. Some call it metaphysics, others call it madness. But Webb keeps collecting data, and the data doesn't lie. What we're seeing forces us to ask harder questions. Not about galaxies, but about assumptions. About the very nature of randomness, time and space. If the universe has memory, what is it remembering? If there's structure, who or what built it? If patterns exist on a scale this vast, are they accidental or intentional? It challenges not just physics, but philosophy. Not just equations, but existence. Because if the cosmos is not a chaotic accident, if it is ordered, if it carries the scars of previous cycles, the imprints of design, or the residue of information, then everything changes. We are not staring into an empty, meaningless abyss. We are staring into something far older, far more structured, and possibly far more intelligent than we ever dared to believe. Webb hasn't just pushed the frontier of astronomy forward. It has torn open the ceiling on what we thought reality was. What was supposed to be a tool for confirmation has become a mirror. And what we see in that mirror isn't just space and time, it's the possibility that we were wrong about both. So yes, the James Webb Space Telescope has stopped the world. Because when the universe looks back at you with symmetry, structure and signals, you stop. You rethink. And maybe, just maybe, you start listening. If this left you thinking differently, you know what to do. Like, share. Subscribe, there's more coming. The silence after a revelation is heavier than the revelation itself. Because once you see it, once you know it, there's no turning back. That's the weight the James Webb Space Telescope has put on the shoulders of science, of humanity. It's not a question of data anymore. It's a question of what we do with it. A question of how long we can keep pretending the old rules still hold when the sky is now filled with evidence they don't. For decades, cosmology held firm on one central idea. The universe is random, expanding, cooling, born in chaos, growing toward entropy. No order, no purpose, just physics and time. But that foundation is cracking under the pressure of what Webb is now showing us. It starts with timing. Webb peered into deep space and saw galaxies that formed just 180 million years after the supposed birth of the universe. That may sound like a long time, until you remember the math. In cosmological terms, that's the blink of an eye. That early, space should still be hot, violent, filled with gas too turbulent to form anything coherent. But these galaxies aren't chaotic. They're structured, massive, evolved. That doesn't just raise eyebrows, it rips up the timeline. Either galaxies formed faster than the laws of physics currently allow, or the universe is older than we thought. Much older. Either option throws every textbook into the fire. And yet Webb keeps adding fuel. The exoplanet HIP 65426b adds another layer to the crisis. It's orbiting a young star. Young enough that the dust around it shouldn't even be done forming planets. And yet here it is, a gas giant, intact, massive, orbiting at a distance that makes no sense under any current formation model. There's no way this planet formed where it is. No way it migrated there within the window allowed. Which means either something is broken in the model, or there's another mechanism entirely. Something we've never seen. Something we've never even thought to look for. That's not speculation, that's deduction born from data. When the known theories fail again and again, it means there's something deeper, something foundational, that we've misunderstood. Now bring in the gravitational lensing. That nearly perfect Einstein ring. Here's the thing about gravitational lenses, they're never perfect. They're distorted, twisted, the result of random, uneven distributions of mass warping spacetime. But Webb captured one so precise, so circular, it forced cosmologists to confront a haunting possibility. What if spacetime isn't as chaotic as we thought? What if, beneath the surface of randomness, there's geometry? Because that kind of perfection doesn't happen by chance. Not at that scale. Not across billions of light years. When you start finding symmetry at cosmological distances, you have to start asking harder questions. And those questions don't end at the edge of the observable universe. Webb is revealing that the large-scale structure of the cosmos, the so-called cosmic web, isn't just a tangled mess of filaments. There's regularity, patterns, filaments spaced in predictable intervals, clusters echoing across space in ways that suggest blueprint rather than accident. A grid, a framework. If these were small patterns, we'd call them artifacts, coincidences. But they span the observable universe. Patterns that stretch across time and space, repeated with mathematical consistency. It leads to an uncomfortable implication that space-time itself may be governed by principles beyond the randomness we once assumed. That order is not a byproduct of entropy-defying luck, but something baked into the very structure of reality. And then there's the silence that isn't silent. In a sector of space previously believed to be completely void, utterly empty, Webb detected light pulses. They're not random, they're not one-off anomalies. They're regular, repeating, rhythmic. We're not talking about known pulsars or quasars. We're not talking about magnetic activity from neutron stars. There are no visible bodies, no stellar activity. Just space, empty, cold space, and a signal. A pattern. Scientists are cautious, they always are. That's their job. Rule out everything before considering the extreme. But the extreme is getting harder to ignore. Because the combined weight of all these findings, early galaxies, rogue planets, structured dark matter, symmetrical lensing, geometric filaments, and now rhythmic light pulses from voids, it builds a picture. One no one was prepared for. It suggests intention. That word is radioactive in scientific circles. Say it out loud and you'll be labeled fringe, speculative, ungrounded. but it hangs in the air all the same. Because if these patterns, these alignments, these impossible structures were happening in isolation, you could dismiss them. But they're not. They're happening together. Again and again, Webb is showing us things that defy our assumptions, not because they're strange, but because they're too ordered. The universe is supposed to be messy, unforgiving, unfeeling. But the cosmos Webb is revealing feels different. It feels deliberate. And that's where the conversation turns from science to philosophy, from cosmology to meaning. If the universe contains structure, does it contain purpose? If it contains memory, what is it remembering? If dark matter is not random dust, but structured scaffolding, who or what built it? There are emerging hypotheses, none of them proven, many of them controversial. Some physicists are considering the idea of an informational universe. One where reality is not just energy and mass, but computation. A system that processes information, one that evolves, remembers, maybe even learns. Not consciousness in the human sense, but intelligence on a scale we can't yet define. Others suggest that these anomalies may point toward prior cosmic cycles, that the Big Bang wasn't a singular event, but one in a repeating pattern of expansion and collapse, that the universe has done this before. Many times. And if that's true, the structures we're seeing, those too early galaxies, those impossible planets, they may be echoes, leftovers, fossils from a universe that came before ours. In that context, dark matter becomes more than just an invisible mass, it becomes a carrier of history, a record, a memory bank. One theory gaining traction is that the geometry of the universe isn't accidental at all, it's a manifestation of information preserved through cycles. The universe remembers through shape, through form, through symmetry. And the implications of that are staggering. Because it would mean we're not just floating in an empty, indifferent expanse, it would mean we're part of a system that remembers. A system that keeps track. And maybe, just maybe, a system that responds. That's the final blow, the one that breaks the spell of certainty. Because for decades, we believed space was silent, cold, dead. Webb says otherwise. The light pulses from the void aren't random. They repeat. They have rhythm. They carry structure. No one's calling it a message, not yet. But it behaves like one. And if it is one, then it raises the ultimate question, who or what is sending it? The silence that follows isn't scientific. It's existential. Because if we're seeing the fingerprints of intelligence, if the universe is broadcasting patterns, if the foundations of reality are shaped by intention rather than accident, then we are no longer alone. Not just in space. Not just in time, but in thought. This isn't just a shift in astronomy, it's a shift in everything. From our models of physics to our place in the cosmos. The James Webb Space Telescope wasn't supposed to do this, it was supposed to confirm, to refine, to fill in the blanks. Instead it tore the page in half. And what's on the other side is a universe that doesn't just expand, it speaks. It remembers. It knows. If that stirs something in you, if it unsettles you or electrifies you, then you've heard it too. So now the silence isn't just heavy. It's charged. Because once you admit that the universe might be more than motion and mass, once you accept the possibility that something deeper is happening, you can't go back. Not to comfort. Not to certainty. Not to the old models, propped up by equations that no longer fit the sky we're looking at. The James Webb Space Telescope didn't break physics. It revealed that we were already standing on cracked ground. And here's the part no one wants to say out loud, we've been ignoring this for a while, hints have come before. Oddities. Outliers. But we brushed them aside, folded them into assumptions, called them statistical noise, because it's easier to do that than admit the foundation might be wrong. Easier to protect the model than confront the consequences of rewriting it. But Webb doesn't care about comfort. It doesn't care about consensus. It doesn't operate on human timelines or academic caution. It just sends back data, brutal, brilliant, undeniable. Galaxies too big, too early. Planets in places they can't be. Gravitational rings shaped with surgical precision. Dark matter behaving not like scattered dust, but like scaffolding, intentional. aligned, maybe even encoded. Light pulsing in perfect rhythm from the nothingness. And symmetry. Everywhere, symmetry. The kind of symmetry that makes physicists stare at their screens a little longer than they used to. The kind that starts to feel less like coincidence and more like communication. Not the kind with words, but with structure, with mathematics, with design. You start to realize, if this is all real, if it holds under scrutiny, then we're not at the end of discovery. We're at the edge of something unthinkably vast. A truth too large to fit into the theories we've been using to make sense of the sky. A kind of intelligence, or at the very least order, so woven into the fabric of the cosmos, that it makes randomness look primitive by comparison. And maybe this isn't the first time we've reached this edge. Maybe civilizations before us, if they existed, saw the same patterns, felt the same vertigo, and drew the same breath before the leap. Because once you ask the question, what if the universe is not random, you start to see that it never was. It was just waiting for us to notice. If you're still here, still listening, then you already know, this story isn't finished. It's barely started. Like, share, subscribe. Because this isn't about space anymore, it's about everything.